G'day and welcome to the fifth video on integration. In this video we're going to look at integrating 1 on x. Now we've seen this, I think I showed you this back in video 1, but I didn't really explain it or explore it a lot, but in this video that's what we're going to do. And this is 7.4 from your textbook. Again, I'm going to use differentiation to kind of help us to understand. Now we know that when we diff a log graph, we actually end up getting 1 on x. But if I draw those two functions there, if I draw a log graph, which it looks like this one here, and if I draw a 1 on x, I end up getting this one down here. Now you can see that when I get the diff of a log function, I actually don't have anything on the left hand side. I've only got things on the right hand side. So when I diff it, I actually only end up with this right hand side part of the graph, which is okay. It means I can ignore this left hand side. I guess it becomes a little bit of a problem when we integrate things, because often we will integrate the entire graph, but in this case we're actually going to get more than what our original function was. So I'll explain, hopefully I'll explain that a little bit more. We know that if we integrate this function here, we're going to get back to our original. So if I integrate f dash of x, I'm going to end up with f of x, and obviously the plus c on the end. So if I integrate 1 on x, I'm going to get back to log x and then plus c. But have a look at this. When you integrate a hyperbola, you'll actually get two parts. You'll get this part over here, which comes from here, and you'll actually get another part which is going to be over here somewhere, because you know, when x is greater than 0 you get this, and when x is less than 0 you've got this as well. So technically the other graph should look a little bit like that. Probably not like that. It should look a mirror image, which is something, not even that. Let's one more time. There we go. That looks a little bit more respectable. So we actually get a mirror image that should look like that as well. Now, I don't know if you guys can remember this graph, but that graph actually just looks like the absolute value of x, natural log of absolute value of x. So when we integrate 1 on x, we end up getting natural log of x plus c, absolute x plus c. To be honest, it probably doesn't matter that much. Most exam questions won't actually require you to do this. But I do remember one exam, I think it was back in 2009, where if you didn't know this vital piece of information, you couldn't get the answer to a multiple choice question. So I would encourage you to just do this as a natural default anyway. Okay, so here are a couple of examples of integrating the 1 on x. So I've integrated here 3 on 2x dx. The 3 on 2 I can take out as a common factor. Sorry, not a common factor. I can take out at the front because it's a constant. So it becomes 3 on 2 multiplied by the antidiff of 1 on x dx. Now we know that 1 on x, integration of that just becomes log of absolute x plus c. So the 3 on 2 is just multiplied by that. Similarly with this one here, I can take 7 out as a common factor. Why do I keep saying common factor? I can take 7 out because it's a constant, and that becomes integration of 1 on x, so therefore the answer then becomes 7 log absolute x plus c. The next example I've got here, I can take the 5 out the front as a, not as a common factor, but as a constant, and then I can integrate 1 on x plus 1. So what I guess I'll do is I'll go, that's 5 multiplied by 1 on x plus 1 dx. And then I can get the antidiff of this 1 on x plus 1, which becomes a natural log of absolute x plus 1 plus c, or multiplied by 5. For the final example that I've got over here, you'll need to use this rule that I've got just to the right hand side. If I've got the integration of 1 on f of x dx, the integration of that ends up being the natural log of absolute value of f of x, which is what we've had before. But then I also need to do 1 divided by f dash of x as well. And obviously I've got the plus c. We haven't really needed to worry about this so far because we haven't had a number in front of x, but in this case we will down here. So the diff of this one here, 2x plus 3, the diff of that is 2. So I've got 1 over 2 multiplied by the natural log of the bottom, which is 2x plus 3 in absolute signs, and then the plus c. So that's integrating 1 on x. Hopefully this has been helpful. In the next video we'll look at my second most favorite part of the course, which is integration by recognition, doing stuff that we can't do but using manipulation and special rules to find out how to do it. So stay tuned, that would be great.